This presentation was recorded at mvcConf. For more content like this, go to www.mvcconf.com. JetBrains, the leading vendor of professional development tools, now offers a range of new products for .NET developers. In addition to ReSharper, the top-class productivity extension for Visual Studio, you can now use .cover to run coverage analysis for your applications, .trace to find performance bottlenecks, and use TeamCity and UTrack for a perfect combination of continuous integration and issue tracking software. Go to www.jetbrains.com for more information.
Hey everyone, this is Raj Kamal. I would like to thank you for taking the time to attend today's virtual ASP.NET MVC conference. Our speaker for this session is Todd Anglin. Anglin will be talking about the 4 C's of web asset optimization. Todd Anglin is the chief evangelist for Telerik, a provider of development tools and user interface components for .NET. Before joining Telerik, he worked for a large Fortune 200 financial services company where he learned the way of the enterprise, big budgets, big projects, legacy systems, and incessant measurement. He now leverages this enterprise experience to help Telerik make components and tools that makes the life of all developers as easy as possible. Todd is an active author and speaker in the .NET community, focusing on web development technologies. He's a Microsoft MVP, founder and president of the North Houston .NET Users Group, and an O'Reilly author. And now I hand the floor over to Todd Anglin.
Thank you very much for the introduction, and thank you everybody for joining me today for the next session here in the busy MVCConf day. Hopefully you've enjoyed the morning's content and the keynote. Obviously a lot of great MVC content happening today, and hopefully this next session will be no different. Now we've got a lot of information to cover here today. This is really a professor session. This will be great for taking notes. I'll provide the slide deck. There are lots of links in the slide deck that won't be on the screen. That will be available to you afterwards for your own additional follow-up and research. But if you've ever had any questions about how do you go about optimizing a website, this session should provide you with a lot of the information you need and should dispel a lot of the myth that perhaps is out there. So the session is the 4 C's of web asset optimization, making the least of web assets with caching, compressing, combining, and CDNs. And just as a precursor, if you're not already engaged with Telerik on Facebook and Twitter, we are there, twitter.com/Telerik and facebook.com/Telerik. We're always giving away various things there. It's a great place to stay plugged in for the information about our tools, such as the open source extensions we talked about earlier today. So make sure you're joining us there if you are on Twitter or on Facebook. A brief introduction. Actually, I had a great introduction here coming into this, so won't go over the information, but just so you know who's talking on the other end of the faceless presentation today, and where you can find me online. TelerikWatch.com is where I blog most often, and then if, again, you're on Twitter, I'm also there with my no traffic updates or what I'm having for lunch promise, just information about web development primarily. So if you're a web developer, you're interested in today's topic, feel free to follow along at Todd Anglin on Twitter as well, and you should keep up with some good resources there. And then my one slide, just so you know who I work for. If you've not heard of Telework before, hopefully you will have heard of them before today is done. Obviously, a sponsor of today's mvcConf event. We're really aiming to be an all-in-one provider of tools and UI components for .NET development. And this really extends beyond just the construction of .NET software to both the planning and to the testing, with things like Team Pulse launching next week. In fact, if you're interested in Team Pulse and Agile Project Management, make sure you join us next Tuesday. We'll have a webinar and be giving away free licenses to Team Pulse to everybody that joins then. And our free and open source MVC extensions. So if you're building MVC applications and you want to build rich MVC views, those open source MVC extensions are available today, and you can grab those on Codeplex or on Telework.com and use those. But at a high level, we're building a toolbox so that no matter what you're doing, no matter what the project is, you have tools to hopefully save you time and help you build higher quality software and release it, obviously, on time. So that's the one slide here. We've got so much to cover that we're not going to really spend much time up front and try to just get right into this. We're going to start today by talking about optimizing the web 101. What does it mean to optimize for the web? What are the concepts that we're talking about here? And then we'll break down the 4 C's in detail and talk about how we can optimize by using combining, how we can optimize with caching, compressing, content delivery networks, and then, of course, any questions you have, hopefully we can provide some answers as well. We've got about 90 minutes worth of content to shove into about 45, so we'll be moving rather quickly. If anything goes by too quickly, just be sure to grab the slides and the recording afterwards, and hopefully you'll be able to catch up then. So without any further ado, let's jump right into it so we can get through as much as possible. If you do have a question today as we go through, make sure you're using the Q&A manager inside of live meeting, and we will interrupt if there's some great questions there. I've encouraged the moderator to interrupt so that we can answer those as we go along. So Web Optimization 101, the professor session. How do we get you guys up to speed to make sure we're all on the same page? Well, first we need to start by defining optimization to make sure we're all using the same understanding of the word. Optimization can mean a lot of different things really when it comes to talking about software and websites in particular. But today we're really talking about performance optimization as measured in perceived page load time. So there are optimizations that you can do to optimize server resource usage, optimizations that are more intended for helping with scalability of a web server, and obviously optimizations for security, content, SEO is a major shape and type of optimization. Often we find that engaging the things we'll be looking at today will have an indirect impact on some of these other aspects, such as SEO. What we're really looking at today is what techniques can we apply to optimize websites for optimum page load time. So if that's the kind of optimization we're aiming for, then the question we have to answer just up front, if we need to know why we're optimizing in the first place, is what makes the web slow? What is it that we are, in fact, needing to optimize? Why is there even a need for this type of optimization? Well, first and foremost, before we even list anything, we have to acknowledge that connection speed is something that will make the web slow depending on your users and where they're accessing from. And unfortunately, that is by and large one of the things that we just have very little control over, and it's not something that we directly can optimize. So we're going to acknowledge it, but say it's not something that we can directly control, so we'll just be aware of it, and we'll keep in mind that this is a good reason to have a highly optimized website so we're experienced equally well across all connections. So the things that we can control, page weight certainly plays a big role. How much data are we sending from the server to the user? HTTP requests, how many requests are required for our page to load? So when a browser visits our server, how many back and forth conversations need to be had? What's the internet latency between our server and the user? And while we can't directly control the internet latency any more than we can control the weather, we can try to do things to minimize internet latency. Poorly placed script tags and CSS tags actually have a huge impact on how a page is perceived to load, sometimes even more than how it actually loads. So this difference between perceived page load time and actual page load time can be impacted by how we place these tags. Server processing certainly takes a toll. Anything that we're doing on the server that takes a long time, and this is often a challenge with web forms, will impact our page load time. And believe it or not, complex HTML will actually have a bigger impact than you may realize. Browsers ultimately have to understand, parse, and then render and lay out any HTML objects that we place on the page. And if we don't take certain steps for optimizing our HTML, be it semantic HTML or even omitting important yet seemingly insignificant tags like the width and height on an image, that incurs a greater processing penalty in browsers that makes a page slower to load. And, of course, DNS lookup delays, which is sort of a counterpoint to something we'll talk about later, but we have to be careful about over-optimizing, so I'll throw that out here, because you can actually make your website slower by trying to optimize too much. So it's important to understand where the trade-off is. For today, though, we're really going to focus on page weight, HTTP requests, and internet latency, because when we talk about the 4 C's, those are things that we can address very quickly, and given our time today, that will allow us to focus on something that we can wrap our mind around. So as we've identified now, the 4 C's of web asset optimization are combining, that is, taking CSS, JavaScript, and even images and transforming them from multiple requests into single requests. Caching, which is setting the appropriate HTTP headers on our response objects so that they are cached by the browser and not loaded any more times than necessary. Compressing, which is basically zipping our resources on the server, compressing our resources on the server before sending to the browser, and then allowing the browser to decompress them. A standard that almost, I think the stats are 90% of web browsers today support, and it's only the oldest browsers which aren't supporting compression. And, of course, content delivery networks, which is taking resources that are static most often and moving them off of our primary web servers onto cached web servers that are often closer to our end users than our actual web servers may be. All of this is really centralized or oriented around optimizing the delivery of CSS, JavaScript, and the related resources. This is what we mean by web assets. So CSS, JavaScript, images, and really HTML or text we could even toss in there as well. So let's start then by talking about how do we optimize HTTP requests. How do we go about combining things? This is the first C. And one of the ways we can do it is by, in fact, optimizing these HTTP requests. According to the Yahoo Performance blog, and Yahoo has a great set of resources for anybody interested in the idea of performance optimization, 80%, I think we've got a request for control that I think I will deny for now. 80% of the end user response time is spent on the front end, which means that what your page is doing, the time it takes for it to load from your user's perspective, most of that time is not being spent on the server processing or talking to your database, getting that data to your server, and then sending the response. It's happening on that front end as you wait for things to download, be processed, and rendered. So there's a certain delta in how much time you should spend optimizing the server and the server process time, your .NET code, versus optimizing things like HTTP response codes or HTTP requests. You may see a significant gain in perceived speed if you optimize there. Why is HTTP requests such a problem, and why does it create such an impact on page load performance? Well, first is slow user connections. Obviously, if I have a slow connection, a request is going to take some time, and each request is going to take that amount of time. But then the real problem that often is the case with today's modern browsers, where a lot of users have the bigger bandwidth, so you don't get hit by connection speed limits, is concurrent request limits. Limits imposed by browsers, operating systems, and just proxies, environments in general, that limit the total number of concurrent requests that you can send to a server. HTTP 1.0 spec says, or actually 1.1 spec says, that a browser should limit connections to 2 per host name and 6 total. Now, the reality is that that's actually quite different today if we look at the way browsers are actually behaving. It also suggests that JavaScript blocks should block parallel downloads. So if I'm executing a block of JavaScript, an embedded inline block of JavaScript, I should at that point delay any additional downloads, because that JavaScript may have an effect on my page or what's going to happen next on my page, and I don't want to process additional code ahead of that. Now, that's also changed a lot in modern browsers. Modern browsers are starting to get smarter about how we work around these limits. In fact, if we were to look at modern browser limits, and you can get a full in-depth report by going to browserscope.org. It's a great place to inspect what browsers can do today, especially in the arena of optimization. We find that most modern browsers actually allow 6 requests per host name. So if you're going to www.mvcconf.com, then you could make up to 6 parallel requests to mvcconf.com and up to 54 total for IE 8 in this case, or 30 total for Firefox 3 and 4 across all tabs. So across the browser, that's your upper limit. So the limits are not quite as severe as the specs would suggest. Of course, IE6 and IE7, two not entirely uncommon browsers today, still does limit you to 2 requests per host. And some browsers, like IE6 and 7, and Opera 10, surprisingly, do still block on scripts, which means that you won't download any additional resources while you're executing JavaScript. Many of the other browsers have gotten smarter to where they'll actually download those resources but not process them when there are JavaScript elements executing. So some browsers have actually gotten a lot smarter about that. Still, this chart represents a best-case scenario. And why do I say best-case scenario? Because if you're in an environment, let's say, behind a proxy, or if you're on a slow connection speed, this chart could look very different. IE8, for instance, will automatically throttle the max request per host down to 2 if it detects you're on a dial-up connection. And proxies will often end up throttling requests because all requests end up looking like they're coming from the same place to the server. The request limits in general were imposed in the first place to save servers from being bombarded by floods of requests, and there are often security measures on servers if we send too many requests at one time that trigger alerts that might signal something like a denial of service attack. So there is a sweet spot in between the minimum and maximum, but generally today we're looking at 6 requests per host concurrently. There's also something called HTTP pipelining you should be aware of that's in the 1.1 spec. And essentially what this says is browsers can cram multiple requests into single TCP packets. It does require server and client support to work, so it does require some cooperation on both ends. And unfortunately, today's browsers don't have just broad support for this. In fact, it's only Opera and Firefox which have support at all, and Firefox support is disabled by default. So this is not yet widespread or common, but as it becomes more common, there'll be an additional way we can start to send more requests and get past this throttled limit of 2 to 6, depending on the browser you're using. Why does all of this matter? Well, it matters because if we have a website that has, let's say, tons of images or tons of JavaScript files or any number of external resources that we have to download in addition to our HTML, that throttled limit is going to limit how much we can do at one time. So we'll have to do these things or do our work in chunks and then wait for the user's browser to process that before it can continue. So we have 2 solutions, 2 things that we can take notes on how we can start optimizing our pages for the HTTP request problem. One solution, obviously, is just flat out reduce requests, find ways to optimize our page to reduce the number of requests we're actually generating. And the other option is to say, no, we've reduced as much as we can. Now we're going to try to work around that request limit. How can we request more than 6 things at a time? So some of the ways we can achieve these solutions. We can simplify our page design, reduce elements. That's obviously in column A, so that's just kind of starting with the basics. But we can more easily, perhaps, if we already have an optimized page, start to work around the request limit by using multiple host names. So that 6 request limit is per host name. So www1, www2, or whatever it might be is considered a separate host name. So I can spread my requests across host names and then send off more parallel requests. I can also, instead of simplifying my page design to reduce elements, I can just combine elements into single requests so that I don't have to make as many individual requests for JavaScript, CSS, or images. So by using these last 2 options, host names to work around and combining files to reduce, we can actually do a lot to optimize around the HTTP request problem, one of the major bottlenecks on modern websites. So let's look at this in practice and implementation. Let's start with images. We'll work our way back. So how do we optimize images? We can optimize images using CSS sprites. And basically a sprite is a technique where we combine images into a single image file and then use CSS background position to display the appropriate portion of that file on the page. So to put that in more concrete terms, we may have a collection of, let's say, individual browser icons, as I'm showing here, where each of these various icons is a separate file we want to display. And if we were to sprite this, we'd actually turn this into one single image, where we download one request, a little bit larger, but browsers have bandwidth, so they can handle the size all right. It's that HTTP request overhead that gets in the way. So we download a single large image, and then using CSS, we essentially create a viewport. So if you can imagine that this viewport is a div on our page, and we're using CSS background position to show the appropriate portion of the image, then to show another icon, all we have to do is adjust background position, and essentially the browser will slide or move or manipulate the background image so that we only see the portion of the sprite we want to see on the page. So this is an important technique for optimizing images in modern websites. You can build these yourself, and often you end up doing that as you optimize sites. You certainly want to make sure as you consume tools like the Telerik extensions that this is being done for you. And there are tools to help you do it automatically. One in particular is the spritegen.website-performance.org. And what we're actually going to do is take a look at that as we move along. So let me open up Chrome here. This is the CSS sprite generator, and what it allows you to do is select a zip that contains a number of images, and then it will automatically combine those images into a CSS sprite for you and provide you with the necessary CSS to actually consume it. So if I come to this choose file, I've actually created a zip archive with some images. So if I come to my icons folder here, I've got some icons. We'll use the PNG format. I've got about 130 or so icons in here, so I'll open this up, all individual files. Now from here I can set some options, obviously, how do I want it to go about building this sprite. In fact, it's very important that you make sure you pick the appropriate vertical or horizontal orientation. Depending on what will be in your design will be very critical to how you choose to lay out your sprite, because you'll end up with image bleeding where you see the next image in the sprite when you don't want to if you don't lay it out the appropriate way. For now, I'm going to leave the defaults. I'll leave it to you to explore your various options and click Generate Sprite and CSS, and I'll show you what we get. We get a collection of CSS rules, and here you can see that for my various sprites, it's used my image names here for the class names, which my image names were numbers. We can see what it's doing for each, though, is it's simply setting the background position. So we see background positions being shifted, in this case, incrementally down as we display each subsequent sprite. And if we look at the image that was generated, in fact, we'll click on this, go ahead and save this and open it. We can see all of these individual icons that were uploaded in that zip have now been combined into this single file. So we can see all these images here in one file. That would be one request. If we look at the properties for this, we can see that what's been output by the CSS generator is actually 245K, and I highlight this for you simply as a cautionary tale. CSS generator is a great tool to help you get started creating your sprite, but you're definitely going to want to optimize it further if you're going to use it in a real site. And I did this earlier, and if you take this into Photoshop and run it through just a very simple save for web through Photoshop, for example, you can take this same image and reduce it by about 90%. You can take it from 245K here down to about 20 or 30K. So this can be optimized through a better saving program. This is a great way to save you time laying out the images and building your sprite. You can also build sprites dynamically. You can write code in ASP.NET that could take images, build your sprites on the fly. Of course, you need a good caching strategy there, and I've included a link in the slides to code that shows you how to do that. But CSS sprites are a great way to start optimizing your HTTP requests. The next thing that we want to look at, though, is more about how do we go about working around that request limit. So I'm going to jump over to another project here. And let me go ahead and close some of these windows since we're now in our small resolution. And we'll get all this so you guys can see as much as possible. In fact, I'm going to jump over to a different Visual Studio. Let me go ahead and go to the desktop here and concurrent web requests. So in this example, what I've done is I've just very simply taken a simple MVC page, and with some very rough code, I'm simply rendering an unordered list of images. And these images are coming from a simple website I've got up on the TelerikWatch.com domain. And I've set up some DNS records. And in our first test here, we're actually just going to use a single DNS record. So we're going to use image1 as our host name. We're going to see how the browser handles this large number, in this case about 130 requests, when we download all these images from the same host. So I'm going to go to a browser where we can view this. In fact, I think I've got it loaded in Firefox. So here's what the page looks like. You can see my page. It's generated. Each of these is an individual image. You can see that because I can drag each one. You notice that that's individual. So what I want to look at now then is how does this perform when we download it with a single host. So I'm going to Control F5 on this page to clear the cache and download all of my images again. And it's going to process. Now as this is downloading, remember what we just talked about. The default browser limit per host name is 6 requests. So let's see if we can see that in what we examined with Firebug. If we scroll down here, we can see that the green represents connection starting. Here's our image downloading is starting. And sure enough, 1, 2, 3, 4, 5, 6. There's a batch of 6. Here's a 1, 2, 3, 4, 5, 6, a batch of 6, a batch of 6. We can see our browser basically batching our requests 6 at a time as we scroll down here. You can kind of see this pyramiding effect. And some of the delays are because we start to overwhelm our server. We start to send so many requests, but we're stair-stepping down, loading these images. And you can see it takes about, in this case, 5 seconds overall for the page, 3.4 seconds for about each image. So let's see what happens then if we try to work around that request limit by using 6 different host names. If we use 6 host names, in theory, we should be able to batch much more than 6 at a time. We should be able to, in theory, do 36 at a time. So if we go back to our Visual Studio project, and I'm just going to change this to 6 because this is how we're basically incrementing our host name here. Instead of image 1 as my host name, it's going to be image 1 through 6. If we go back to Firefox and see the effect, go ahead and reload this with Control F5 to clear the cache. And now we see a very different picture. If we start scrolling down now, we don't see that pyramiding effect of requests. In fact, we see a lot of requests firing off at once. In fact, I don't know the exact count there, but we see lots of requests fire off. Then we see a lot more requests fire off, and we can see it's happening a lot faster. We also see it's taking a little bit longer sometimes for the server to respond. That's because now we're bombarding the server, even though we're using different host names, we're bombarding the same server, so we're bombarding it with more requests. But ultimately, it allows us to download our images much faster. You see the average image now is less than a second to get all of our images downloaded, even though the page takes about the same amount of time to process. So by changing host names, and again, you can see it done here, images rotating through image 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, we were able to optimize that HTTP web request barrier by generating more parallel requests. So here's an easy way to work around that request limit. The other way we can work around this, in addition to CSS sprites or image combining for images and using different host names to work around the request limit, is we can also combine our JavaScript and our CSS. So if I go over to Visual Studio, I've got a simple MVC project again here, and I've added the Telerik MVC extensions. These are the open source and free extensions that Telerik provides for MVC. And 2 of the non-visual components provided in that are the style sheet registrar and the script registrar, which I scroll down to the bottom, you can see our script registrars right here. These are 2 tools that allow us to not only very easily add the necessary CSS and JavaScript for working with the extensions, they also give us an easy way to start optimizing our site's resources in general. So if we go ahead and view this page in a browser, and we'll go ahead and view page source, we can see that right now we've got all of our CSS requests coming in as separate requests. So right now we're generating 3 separate requests for our 2 CSS files for the Telerik extensions and then our common site CSS file. So we can get around having to have separate CSS requests if we combine all the CSS into a single request. And that's something that the Telerik extensions for both style sheets and scripts can do. And it's actually quite simple. If we go back to our project where we've got our style sheet registrar added, here you can see we've added the various scripts, or in this case, style sheets to our configuration. And for each group, we can set additional configuration. So for my default group, for instance here, I can come in here, and you see I have the options when I go to my Fluent API to combine. So I can say combined true. Save this. We have a HTTP handler registered in our web config. Obviously, we have to have something to do this dynamic processing to combine our CSS. But the result is that when we go back to the same page, and let's go ahead and reload it. Now those 3 separate requests, we'll view page source, become 2 requests. We're not combining this with that group, so this one still comes down separately, but the 2 requests that were in the combined group are now combined, and we see this encoded string. Now, some people don't like this encoded string. In fact, I'm one of them. I think it starts to look pretty ugly. It reminds me in certain ways of web forms. And the nice thing is that this is simply encoding that is the bare minimum required to communicate to the server with no other knowledge of the page which scripts should be returned to the page or can be combined and then returned. There is an optimization technique that we provide to reduce the length of this, which I'll show you probably in just a minute. But for now, what we want to look at is the fact that by using this technique, we're able to reduce our HTTP requests. In fact, we want to see this actually proof of this. We can go back to our page. If you've not looked at Google Chrome's developer tools, they provide a great set of developer tools as well in the latest versions. So you can click on Inspect Element for the page. And then we can come over here and click on Resources, for instance. And we can see the number of HTTP requests generated and where they fit into the timeline. And here we can see that we've generated one request for our AXT, which includes our combined scripts. In fact, we can look at the content for this here. The content is in a minified fashion before it's been combined because these are coming from the telework extensions. So it's one line, no extra white space. We can see it's all combined there. And then a separate request for our site.css. So an easy way to come explore those requests right here in Chrome as well. So that's HTTP encoding, or rather HTTP request limits, and working around the challenge that imposes by doing this combining. If you want to do more, we'll talk about it as we move along here. So let's do that. The next thing we can do is reduce page weight. So again, the 4 C's: combining, caching, or compressing, caching, and CDN. So we've talked about combining. Let's now talk about how can we compress. So what does page weight represent? Well, ultimately, page weight represents that total size that a user must download before they can actually engage with or interact with your page. And that is generally represented by HTML plus any CSS and JavaScript you reference, plus any images or media. So this could be videos, most often, though, images. All this combines to represent total page weight. And our approach for optimizing each of these various things that contributes to weight is a little bit different. Obviously, with HTML, we can start by making sure we're using semantic rendering, make sure we're rendering the minimum amount of HTML necessary. We can use AJAX to delay loading of some HTML. Obviously, you want to be careful there for SEO to make sure you're not delaying too much. You want to make sure the content's there for things like search bots that don't execute JavaScript. But we can delay some HTML with AJAX to reduce that initial page weight. We can use client-side binding, which allows us to not have to send as much HTML over the wire. Instead, we just send data over the wire, let's say, in this case, with JSON, and then we generate the HTML client-side using JavaScript. So we can reduce how much is traveling over the wire, improve speed. And, of course, we can compress. In fact, for all of these things, except for images and media, we can compress very well because these are text-based resources, and text compresses extremely well, which is why compression is such an easy optimization for websites. For CSS and JavaScript, we can do something a little bit extra. We can actually minify these resources, which essentially means take out all the unneeded stuff we don't need and try to compress it down as much as possible in the physical file before we get to compression. We also want to make sure as much as possible we're putting our CSS and JavaScript in external files, so in reference CSS and JavaScript files, because that allows them to be, what we're going to talk about later, cached. So if we can cache those things, then we don't have to download them with every page, and it doesn't become part of the embedded page weight. Images, on the other hand, we've already looked at sprites. That's how we can reduce images. It's not going to reduce our weight. It's going to reduce our requests. And then obviously, we simply have to use the tools that are available for optimizing images and media. Photoshop, various tools online allow us to compress and smash our files into smaller file sizes. We don't really gain much by using compression in the HTTP sense with images and video because they're already compressed formats. So don't waste your time trying to over-compress those resources. So then we're going to look at two things now when we talk about reducing page weight. We're going to look at how can we actually reduce the bits in the file, so physically make the file smaller before we send it, and then how can we use runtime compression to make it smaller over the wire. To make things smaller before we send it, so the actual physical compression, we're going to use minifying. And minifying is, as I mentioned, simply a technique for reducing characters in JavaScript and CSS files. There are two types of shortening that typically happen if we were to oversimplify it just for understanding. There's the most common and the most basic, which is simply removing unnecessary characters like white space, new line characters, comments, things that don't add any functional value to the JavaScript or CSS files. We can get rid of those in a hurry. And the more complex approach is to actually analyze and understand our CSS and JavaScript and actually start doing some manipulation of the code, renaming internal variables to use shorter names as opposed to perhaps the more readable names we use when we write the files, or renaming internal or private method names to make them smaller as well. So when we use a minifying tool, we can actually go very deeply into taking our original readable JavaScript and CSS and making it as small as possible but still functional. The approach for applying minification is either build time or runtime. Each has advantages and disadvantages. Build time obviously allows you to do this, say, with a release and then ship it statically, so no additional CPU resources are required for doing the minification. And runtime has the advantage of being dynamic, so you don't have to maintain any set of minified files, or you don't have to maintain and keep up to date your minifications. You can just let it happen automatically with your latest versions of your files. So we'll look at both now when we talk about minification in demos. And we're also going to look at compression. 70% is the amount that you can reduce the size of your page, on average, the bytes over the wire, simply by using HTTP compression. This is according to both Yahoo and to the browser scope we looked at previously. 70%. So if you're not using HTTP compression today, you're probably sending way more data over the wire size-wise than you need to. You can make that smaller, which means your users will get it faster, and the page will proceed to load faster as well. To use compression, we need to make sure the browser supports it, and we are told that by the browser when it makes the request via the accept encoding HTTP header. When we see the accept encoding header, we know the browser supports compression. It usually tells what types as well. gzip is the most common. And then the web server or a tool will do the compressing and send back the compressed data, at which point the browser will decompress it. When it comes to compression, there are do's and don'ts. Do compress HTML, JavaScript, CSS, XML, JSON. Any text format does very well to compress, so make sure you're compressing it. Don't compress PDFs, JPEGs, PNGs, zip archives, anything that already has compression built into the file format. You're not gaining anything and you're only wasting server resources. So let's look at how we can apply both of these techniques. And I'm going to start by showing you manual minification. And there are a couple of tools available to you for doing minification. I've included links in the slide deck. Yahoo provides a very popular YUI compressor. In fact, there's a great .NET port of YUI compressor that I'll show you as well. And Microsoft actually provides a pretty powerful tool called the Microsoft Ajax Minifier. Both tools are capable of compressing both JavaScript and CSS, and both tools can be integrated into MS build processes, so it's part of your release build cycle, or you can actually execute these from code as well. In this case, I've opened a command prompt that comes with the Ajax Minifier. There's a version 4 out released this year, so make sure you grab that if you've not looked at it lately. And I've grabbed an old JavaScript file from a website project that I'd done some time ago that had never been really optimized. And if we open this to look at what it starts with, here's what we've got. And it's pretty ugly. Size-wise, we're looking at about 18, 19K. And if I scroll through this, you can see it's just basically a lot of JavaScript code. There's comments in here, there's long names, long variables, lots of things in here that, while helpful for maintaining, don't do much for the actual processing at runtime. So I'm going to go ahead and delete this because I've run this before. And I'm going to go ahead and run the Microsoft Ajax Minifier here from the command prompt. And I'm adding the -analyze option as well, so it'll actually tell us what it's doing. So Ajax min, the name of the file I want to minify, the output file name, in this case just the same file name with min added, and the analyze option. And the cool thing about the Microsoft Ajax Minifier, if you've never used it, is that it not only tells you how much it was able to compress the file, in this case a 49.7% minification, so we started with about 19K, and we ended with about 9.5, 10K, so almost half the original file size. But it goes a step further and it shows you here's how it would compress additionally if you use gzip compression when you serve this from your web server. So we see we can take our resulting almost 10K and turn it into about 3K when it goes over the wire. So when we take a 19K JavaScript file, compress it with gzip and minify it with this tool, we can send just 3K over the wire. And that's a huge savings. In this case, it tells us about a 70% savings, just like we indicated in our slide a moment ago for this JavaScript file. And the nice thing with the analyze option is you can come see exactly how it did that. You can come see what it renamed variables to. If you scroll up even further, you can get some information about what you may be doing wrong. It shows you performance warnings, responses defined but not referenced. Come in here, find things that you're not even doing in a very optimized way within your file. So the minification tools that are available are very powerful, and they can help you take your resources and make them smaller. Now, we've run it manually here. Ajax, the Microsoft Ajax Minifier does come with an MS build task, which you can easily integrate into your VS builds, and that allows you to make this part of your build process. You can also do minification at runtime if we prefer. Now, this obviously requires that you employ some form of caching, because you don't want to run this for every request. But what I've got here, I believe, see, which project do we want? Not this project. Let me give you this project. So in this project, the same project we started looking at a moment ago that Visual Studio doesn't like, we'll go ahead and cancel that and reopen it. We'll roll with Visual Studio's punch here. Go ahead and minimize this and go back to Visual Studio and go back to this app. What I've done is I've basically taken the web asset handler that ships with the Telerik extensions for MVC, which allows us to do compressing, combining, caching, all the things that we want to do for optimizing web resources. And I've extended it a little bit further to actually allow us to do runtime minification as well. So automatically allowing the handler via the HTTP handler that we've got here to take our original CSS in this case and return to us minified CSS. The project that contains that is this extended resource handler. You get some of these windows out of your way again. And let me first go ahead and run this and show you the starting point and show you what the minification can do. So I'm going to Control F5 this. Go ahead and view page source. And what we can see now is, let's just click on, for instance, my site.css. My site.css is coming through, but it's not minified. It's full, comments included, white space characters there, nothing that's helping us reduce this, making just the absolute minimum for being functional. So how can we minify that at runtime so we don't have to go add or configure any complex build steps? Well, using this extended HTTP handler, what I've actually done is referenced the YUI port of the YUI compressor, or the .NET port of the YUI compressor. So you can download this from Codeplex, yahoo.yui.compressor. It's a .NET port that allows me to very simply, from one line of code, say yahoo.yui.compressor. In this case, I'm using CSS, csscompressor.compress. I just hand it the string which represents my CSS content. It gives me back the minified version. So if I want to use this HTTP handler in my project, I can just go to my web config. And I'm going to go ahead and switch my HTTP handlers in my web config from the default handler, which doesn't have that, to my new customized handler. So go ahead and customize this. And then because I need my site CSS to be processed by the handler, I'm going to go ahead and combine it with my other scripts. And I'm going to show you the other option you have for combining at the same time, which is to do it statically via the web config. So you remember I showed you, in fact, if you don't remember, I'll highlight it again. We've got all this extra junk here, which you may not like. That represents technically extra page weight. How can we reduce that even further? Well, if we want to take that further optimization step, we can come in here to our web config, and we can actually define a web assets section. And we can define our style sheets statically. So when we define our style sheets statically, what it allows us to do is come put the path to our resources here, set our combine, compress, etc. in our settings in web config, give it a name. This will be the actual key that shows up on the page when it renders that tells the resource handler where to find the list of scripts or CSS files to provide. And then on our master page, we simply need to change our registration from this to use the shared group. So now instead of using the defined configuration of the page, we're using a shared group with the name S. There's that little S key we set in web config. So with this combined with my new minifier handler run in the browser, we'll go ahead and Control F5 this. Now if we view the page source, view page source, first of all, we see all of our CSS now has been combined into a single link. None of that long extra text. We see there's the key, ID equals S, being processed by our handler, so that's a nice single request. We've really improved our HTTP request limit now. And if I click on this, we can see, if I scroll down, it's been completely minified, including my site's default styles. We know my site's default styles have been minified because my site still looks the same. We can see it still has all the standard MVC styling, which comes from site.css. We don't see any comments or any extra white space in the resulting file. So we've runtime minified our CSS in the smallest possible fashion. So now we've reduced characters, reduced size, we've reduced page weight. So that's one way to reduce page weight. The other way, of course, is compression. And compression is simply applying gzip from the server. IIS by default, especially with IIS 7 and 7.5, has gotten a lot better about this, will give you that compression on static resources. So we can tell that by simply inspecting the headers for any response we get back. So let's go again to our page and use Chrome's Inspect Element tool. And in here we can come and see for our various resources. Let's take, for instance, our telerik.common.min.js. And we can see, is this being compressed? So what's in our response headers? Do we see any compression? In this case, we don't. So it's not being compressed here because we're being served by I believe, no, we're not being served by the development server. We just don't have compression enabled then on this instance of IAS. So what we would be able to tell, though, is if it was compressed, we'd see that tag here. So where can we find some compressed resources to see what that would look like? Well, let's just navigate, let's say, for instance, to our current conference website, mvcConf.com. Let's see what the story is here. View inspect element, resources, let's just pick this. And now we see that some compression is being enabled. We can tell that because content encoding has been set to gzip, which means that the data we receive from the server has been sent in a compressed format, and that signals to the browser that you need to now go ahead and decompress this before displaying it. We've already looked at what kind of savings that this can achieve. The things to note here are that IAS will often do this for you, and dynamic resources like Web Asset Handler or like dynamic HTTP handlers will often need to handle this on their own. So we can enable compression manually, or we can just let IAS handle it. In this case, we're letting IAS handle it, but if we were to use the option that's within the Telerik extensions that we've been looking at, that's there too. Hopefully you saw it. We can simply come, as in the web config approach, set compress true, and this will tell the handler to apply gzip compression to the response. So a couple of options there. So that's page weight. I know we're racing through this. We've covered now how do we minify or how do we improve page performance by combining, how do we improve page performance by compressing, both by reducing bits and by reducing the amount over the wire. Next up is caching. And caching is something that, again, is primarily oriented around controlling HTTP headers. And so to do caching right, it's more about being aware than about really needing to apply a proper coding technique. And since it is one of the simpler ones, we'll kind of run through this one relatively quickly because, again, I know we have such limited time. But here's essentially what happens with caching. If I have a server and I have a browser and it makes a request for a resource, the server will check the last modified time to see if the resource has been changed, and if it has, it will respond with an HTTP 200 or a OK, and here's the data. If, however, the last modified header has not expired and cache control has been set appropriately, we'll actually just respond with an HTTP 304, not modified, which will tell the browser the version you've got in your cache is fine, use that, you don't need to re-download the bits. This has some advantages. It's going to save our server bandwidth, and it's going to make our page load faster. There are two cache headers that are often involved with caching that sometimes are confusing. Cache control, which you see in this example, where we set max age equal to, I think that's about 3 months. And the expires header. The way to think of these appropriately so you don't get them confused in your head, cache control is like sliding expiration, and expires is like absolute expiration. That's really how they differ. And they can be used in combination. So it's going to save server trips, save bandwidth, and if you use a CDN, so something we'll talk about next, if you use a content delivery network for your caching, or for downloading resources and then caching them, you actually gain an additional advantage by being able to use cache resources that may have been downloaded by some other website or some other page because it's coming from the same host name. So that's an additional benefit of CDNs when combined with caching. The E tag is something else that comes up when we talk about caching that often gets confused. The E tag was originally intended to make resource caching easier or more complete by providing a unique ID for each resource. But the reality is these often aren't a very good thing. Now, the example you see here with the E tag unique key followed by a colon and then 0 is IIS 7.5's approach to trying to reduce the badness of E tags. But if you get into a web farm scenario, this is often where E tags go south because you'll actually get a unique E tag for each server that sends a resource, which will start prompting the browser to download those resources more often than necessary. So it actually works against good caching. So the idea was it was intended to help caching. The reality is that the unique ID sometimes hurts caching, especially if you scale up into a multi-server environment. The outcome, the best practice, generally speaking, is just go ahead and turn off E tags, or at the very least, making sure you're using the optimized E tag format as we see here in the case of IIS 7, the colon 0. So something to be aware of and something to check for on your pages. So just to quickly show you what this is, and I see Barack Obama is requesting control of my presentation. I should probably turn it over. Let's go back over here, and let's go to Chrome actually and just take a look. Well, I'll take it back. Let's go to Firefox and look at what we see with caching. So these images I've downloaded here on this page that we've downloaded from my server in this example, we can see that they're being served by IIS-6, which means that you can also see that they're not using that optimized ETAG format. We see this little value, excuse me, let me get that out of your way, this little value after the colon, the 3AB, that would actually be different for every server that serves these resources. So that's how ETAGs become a bit of a problem. In this case, I've got a single server, so it's not a huge problem. I don't really have the ability in the shared hosting to change that. I also see my last modified date, and I don't see any other caching going on here. So that's the kind of caching being applied here, nothing being set explicitly. We see that the 200 requests came in the first time, and if I were to refresh this, we start to see a lot more 304s. So now as I scroll down my page, rather than 200s, we see 304, 304, 304 for almost all of my resources, and the reason being is my ETAG hasn't changed. I've got one server in place, so that makes it simple. And my last modified date hasn't expired, so you can see that the expiration is in the future. And if we look at the response, it's actually coming from our cache. So caching is important to reduce those requests to the server, and you can actually check out with various tools how this works, but we'll talk about those tools in just a minute because the clock marches forward and we've got one more topic to cover. The anatomy of a web request when we talk about internet latency. So when we talk about CDNs or content delivery networks, that's really the one tool we have for combating internet latency because it allows us to Can you guys hear me now? I think you should be able to. It looks like some other presenter may have muted me, which is never very pleasant, but I think we're back online. I'm going to assume that's the case. If I'm not back online, please let me know, moderator. But I think we are, so let's push forward. Sorry about that. It's the challenge when you share single live conference rooms with lots of speakers that can log in at the same time. Barack Obama was here earlier. Maybe he didn't like what I was saying. So what's going to happen is we're going to fire off or we're going to return our HTTP 200 requests with all of our resources and the links to our outside resources. But then for each link, we're going to have to do that same process. DNS lookup, fire a GET request, get the data back, render it in the browser, check the cache. That's going to happen for every JavaScript file, every image, every link. Ultimately, we'll process and render a page. So let's take Microsoft.com, a page with HTML, 4 CSS references, 12 JavaScript references, 43 images. That's 60 HTTP round trips. And if you're not close to the server, that can represent quite some distance. So if you can imagine that my web server is sitting in London, and I'm visiting it from Houston, and somebody else is visiting it from France, the latency for me is going to be a lot larger than for France. Is it fast? Yeah, we're still talking seconds, but it can be quite a bit when we talk about all the setup and teardown required with HTTP. So CDN allows us then to move some of our resources, like our JavaScript and CSS, closer to end users so that that fast response time can be there for all the things that aren't dynamic, JavaScript, CSS, etc.
Todd, sorry to interrupt. The next presenter, Andrew, says that you can keep on going because his session is 2 hours, so you have some more time to talk.
Okay, perfect. So we'll run maybe just a few minutes over then so that we can wrap it all up in a nice tight bow, if you guys will indulge, and then we'll turn it over to Andrew. So there are a lot of CDNs out there that you can use for a lot of the common resources you may already be using in your websites. jQuery, probably one of the most common resources, especially in ASP.NET MVC sites today, is available from a lot of different CDNs. jQuery itself provides a CDN that you can download the latest version from. Google and Microsoft also provide CDNs from which you can download those resources. In fact, if you look across the various CDNs, I've done the homework for you. Google provides probably one of the largest library of just a variety of various JavaScript resources, everything from jQuery UI to Prototype to the SWF object, even the Yahoo YUI library you can grab from the Google CDN. Microsoft provides jQuery validation, which is something that actually Google doesn't provide, all the scripts for the Ajax toolkit, and of course the ASP.NET MVC JavaScript files. Telework actually offers its own CDN for all of the CSS, images, and JavaScript for the Telework extensions for ASP.NET MVC, so you're always free to use that when you do any of your development with our open source extensions. We also offer jQuery. And then you can always use your own custom CDN. So you can use Amazon's S3, Edgecast, Cloud Files from Rackspace. There are a lot of options for putting files and data out into CDNs. The one warning, don't use a CDN if you're building an intranet application. The time you'll save using a CDN will disappear because the latency in an intranet is often negligible compared to what you gain from a CDN. So don't over-optimize again. Using CDNs is quite easy. Obviously, you can do this in a number of ways. I'll show you one technique for the sake of time. If you are, in fact, using the Telework extensions, let me go to a different website here. If you are, in fact, using the Telework extensions, I don't think you guys want to see the Razor implementation of the syntax. So let me go this route. You have the option within your code, and let me get some of these windows out of your way, to configure a CDN directly from the script definition. I think we've got an unmuted microphone, so if there's somebody else with the mic open, maybe we can mute that. And here you can see that what we provide through the Telework script registrar, for instance, is use Telework Content Delivery Network true, and that'll automatically grab the resources for the Telework extensions from the CDN without any extra effort from you. And you can do the same thing often when you're using web forms. You also have with the groups option to specify that it should come from a CDN. So here we've set combining, compressing, and caching all for our CSS. We could also come in here and specify a content delivery network URL and enter the path where these resources should come from when we want to use a CDN. So very simple ways to configure CDNs when working with the Telework extensions. So let me wrap up then on this note and clear the floor for the next session. When you start looking at all these resources, you're looking at all these techniques for optimizing web resources, and we took a whirlwind tour through it today, combining, compressing, caching CDNs. How do you know where to start? Because there's obviously a lot of things you can do to start optimizing. What is the best place to start? The best place to start is measuring. You need to understand where your site is slow today so that you know where to invest the most time in measuring and improving your site. And there's some great tools out there to help you do that. Firebug is one of the tools we looked at today, in addition to the built-in tools in Chrome we looked at. But two other great tools, YSlow from Yahoo and Google Speed, also sometimes called GSlow, from Google, are Firefox plugins that give you great analysis of how your page measures up on a lot of different optimization techniques. You can also use tools like Gomez and Pingdom, which will take external servers, try to download your web pages so that you can see how your sites perform from servers across the globe and not from your own local location. That's great for seeing things like latency, connection speed, and how that affects your page's performance. The main point, focus on real problems you have, not on theoretical problems based on what you can fix, like we talked about today. So my last demo then, just to highlight the tools and how cool they are, because they've evolved a lot over the years if you've not looked at them again recently. We'll once again go to our conference webpage. We'll go to mvcConf.com. And this time we're going to check out YSlow. And YSlow is a tool, as I mentioned, that will profile the page, tell you how it measures up. And we can see here some of the things we talked about, for instance, using Content Delivery Network. We get, unfortunately, an F here on mvcConf. Making fewer HTTP requests, we've got a C. We've got all these external requests. So we could come in here and start applying the techniques that we talked about today, combining, compressing, caching, and turning some of these C's and F's into A's, like putting CSS at the top, so that we can get good scores and we can be told that our page is as optimized as it's going to be But the main point here, this tool will help us look at where to focus first. Come in here, look for the things that are red, start fixing those before you focus on things that aren't as bad. Also use Google's page speed, similar to YUI, but with a different set of tests. We can come in here and see, are we making the best advantage of the optimization techniques available? Another way to make sure our pages are performing up to snuff. Two cool tools, free Firefox plugins, links in the slides. The script registrar and style sheet registrar are part of the open source extensions from Telerik for MVC. You can grab those on Codeplex, Telerik ASP.NET MVC.codeplex.com. They're optimization helpers, and I encourage you to check those out. Otherwise, whirlwind tour, these hour-long sessions that start late, I know are tough. Hopefully you guys are able to grab something out of this, something that you can use to start optimizing your websites. You can find me online most often at TelerikWatch.com. If you're on Twitter again, you have a question about what we talked about today, at Todd Anglin. And of course, if you are still going the old-fashioned email route, that's where I am too. Email me, anglin@telerik.com, and I'll be happy to send you additional resources for optimizing websites. Otherwise, thank you guys very much for your time, and I hope you enjoy the next session.
Thanks a lot, Todd. I appreciate that. We are going to get everyone rolling back over to the next session. So let's do a little prep. This is room 2. The next session is distributed apps and MVC. Andrew, are you want to just test that you're sharing in your audio really quickly? It looks like you're muted currently.
How about now?
Yeah, that sounds good.
All right. Did you want to run the intro video before I start?
We will do that. Raj, are you back? Or
Yes, I'm back.
Okay. I will turn it over to Raj.
This presentation was recorded at mvcConf. For more content like this, go to www.mvcconf.com.